Hey guys, how's it going? My name's Carstati, and today I'm going to be doing something a little bit different that I actually haven't... Is it focused? Yeah, it's focused. I actually haven't really done this before on the channel, but I am trying to do different things. Not necessarily like exclusively different things, and by that I mean not just doing other... or like... I'm not cutting off the gaming videos, I'm still going to do those, but I'm branching out and doing other stuff because I don't want to be just a gaming channel or limited to something. Because... reasons, I don't really know, that's not the point of this video. But the point of this video is I'm doing a school assignment, which is just a science experiment. And I thought I'd make a video out of it because I wanted it to be entertaining. Not that it's not entertaining on its own, but it'll be fun for you guys too. So the experiment is mass of gas. How immature of you. So my goal for this lesson, I have to write a report on the mass of gas. But we have to do an experiment portion. So I'll be writing the report on my own, obviously, because you guys don't want to watch me write a report. But we are going to be measuring the mass of gas. So the hypothesis is, if gas does indeed have mass, then different volumes of it will have a different mass. This could be demonstrated by using a simple balance and comparing the two different volumes captured by means of balloons. Cool. That is a very long hypothesis. Actually, I guess the first sentence, which was written by Dr. Seuss apparently, is the hypothesis. So, materials we need two balloons of the same size. Guess what? We have those. I went to Target where I work and I bought a whole pack of balloons, so it's gonna be fun. Yeah, I'm using orange and white because that's kind of the channel colors, plus red and yellow and other warm colors like that. Next up, we need a meter stick. I don't have a meter stick, but I have this. It's a paint stick. It should do the trick. According to my hypothesis, it'll do just fine. So, next up, we need string. We got string. This is plenty of string. Plenty of string. After that, we need paper clips, but I'm gonna be using, what do they call this? Scotch tape, maybe? I don't know. I'm gonna be using this tape. There's so many different kinds of tape. Don't get on me for this. I have to remember so much stuff. Okay, here's our procedure. Step one is we're going to suspend the meter stick from the middle in such a way as to be able to move the string to balance. We're going to be like cutting the string and then dangling it in the middle. But the first step, because we want to get an accurate spot where the middle is, we're going to use the tape measure that I have here that I didn't even show you. We're going to be measuring this stick. It is exactly 12 inches, which means the center is going to be 6 inches because using math, ha ha ha. And if I can get an accurate read on this, 6 inches is going to be about right in the center there where my thumb is. Yeah, right where my thumb is. So we're going to take this little pencil guy and we're going to mark 6 inches there. And then we're going to take this string, we're going to unravel it. I don't actually have scissors or a knife, but I got my bare hands, which will not work in this. They're not gonna work. Got him! That did the trick. It really frayed the end, but that's okay. So we got our string here. This is a very liberal amount of string, as you can see. I can't, yeah. So we're gonna find our 6-inch mark on the ruler, which is about here. It's on the ruler. It's there. Trust me. So we're gonna do this, and we're gonna feed it. Yeah. Just like this. Do exactly what I'm doing. Make sure you tie the knot exactly how I'm tying it, because this is a crucial step in our process. You reading me? You reading me? You gotta do it exactly how I'm doing it, because if you don't, then you'll die on the inside. That's on. I just did a double knot thing. Then we move that to the 6-inch mark. Should dangle just mother trucker. Okay, what went wrong here? I know what went wrong. It's denser on this side than it is on this side because see the divot? So we're gonna move it this way a little bit. And what do we get? Okay, that didn't work. Okay, that is good. That is good. That is good. See? You would stop swaying. They can see. Good. Alright, now what's gonna happen is I'm actually gonna tape this down so it does not move. And we were probably about an inch, or 3/4 of an inch off just eyeballing it. All right, that's done. So step 1 is completed. Step 2, attach each balloon to either end of the meter stick, making the apparatus balance. Okay. So this is going to be a little bit tricky because, actually, no, it's not. We can just take the difference and then add the balloon that much further in. You're picking up what I'm laying down. So let me explain this to you. Here's our original line. We got right there. You can't even see it. That's the line. That's where the string is. So what's going to happen is, because this side is lighter and less dense than this side, so we're just going to take the measurement of this distance and we're going to put the balloon all the way on the end here. Focus. Camera. Okay. So we're going to take the difference and we're just going to bring it in on this side, and that should do the same. So if we measure here, I'm seeing 7/8 of an inch. So we're going to bring it in 7/8 of an inch on this end. It'll allow me to measure out 7/8 of an inch on this end. Step 2, we got to blow up the balloon. I don't know why it has me attaching the balloons before I blow them up. That makes no sense. But the balloons are going to be different densities, or excuse me, different volumes. And maybe they'll have different densities because of those volumes. That's what we're testing today, is the mass of gas. And mass, let us not forget, is not necessarily weight, it's just the entire, it's not volume, it's like the amount of matter, you know? Because there are 4 phases of matter. It is solids, liquids, gases, and plasma. You got it. I have a plasma ball that I could go get you, but I'm not going to because I'm lazy and I don't want to go up the stairs and get them. So we're going to blow up these balloons. Oh my gosh. Okay. 2 puffs of air in that one. And then we're going to tie this fellow off. I have never been great at tying balloons, and for the longest time I wasn't able to. And I actually have not, I might have tied a few balloons in my day. I don't know. But we're going to get it done today. And this one, we're probably going to do 1 puff of air actually, so. Let's compare. That was a very large puff of air, so we're just going to let a little bit of air out of this one. Nice. Alright. Why is that so much fun? Because it is. Autofocus on the Lumix G7 is not one of its strengths. That is for darn sure. Okay, so we got our 2 different balloons. One is smaller than the other. We're going to tape it all the way on the end here. That looks about right. Nice, nice. That's all the way on the end. So then we still got our line right above the eye in glidden. And this balloon is going right by the eye in glidden. I need to make sure I get this relatively accurate. Okay, we need more tape. Trust me, I am a professional. Okay, nice. That's awkward. So, step 4, attach the balloons as shown in the diagram using paper clips. Now we are gonna see if these balloons will balance or not. So here's our contraption. There's already a hair on this balloon. Here we go. Here's the contraption, and I'm letting go in 3, 2, 1. Oh, 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 we're leaning this way. It's not, alright, stop spinning. It's leaning a little bit. Can you see that? It is not, in fact, balanced. So, this proves, that gas does have mass, is basically what that proves. Our hypothesis was, if gas does indeed have mass, then different volumes of it will have different masses, right? Will have different mass, have a different mass. Yeah, that's the hypothesis. And that hypothesis has been proven true by this experiment. So that's pretty cool, right? Neato Dorito. There goes the balloon. Discussion of our results. Obviously, the balloon tipped in favor of, the stick tipped in favor of the balloon, which had more volume. And this suggests that volume does, or like a greater amount of volume of gas does equal a greater amount of mass, which has, in turn, more weight. And weight is literally just mass with respect to gravity for that specific area on that specific gravitational object pole, because the Earth's gravity is about 9.8 meters per second squared. Fun fact. The moon is about 1.6 meters per second squared. So the gravitational pull on the moon is a lot less on the moon than it is on the Earth. And fun fact, every single object has its own gravitational pull. You and me have our own gravitational pull. This camera is trying to pull me towards it. It's just so small that I can't move towards it. So the greater the mass of an object, the greater the gravitational pull of that object is. I don't even know why I got onto that, but that is just something completely unrelated. The point is, it tipped to the side, which had more air in it. And that means that that volume has greater density, and that proves the hypothesis of volume, a greater amount of volume in a gas does equal a greater amount of mass. There you go. That's pretty much the summary, right? Yeah, that's pretty good. So that's this video. Thanks guys for watching. I just hope you enjoyed this video. Let me know if you want to see more science experiments from me, because I might do more videos with my science experiments. I have a lot of them that I get to do at home, and I've already done one of them. It was literally just measuring the volume using length times width times height for solids that are, you know, symmetrical, and then also using the liquid displacement method for measuring volume, which is I actually have graduated cylinders. So what you do is you fill water to a certain level, and then you put something like a rock in it, which is obviously all sorts of irregular, it has irregular sides and everything, so you can't really measure it well. You place that in the water, and then you measure the difference. So like you measure how much water, or like where the water level is at after the rock is in it and before, and that difference is called the liquid displacement method, and it's the volume of the rock. And if you measure in milliliters, 1 milliliter equals 1 centimeter cubed. And for volume, you're gonna measure in centimeters cubed. So, for example, if you have like 20 milliliters that you started out with, no, I started out with 19 milliliters, and when I put a rock in it, it was measured at 24 milliliters. So that difference is about 5 milliliters, and so the rock's volume is about 5 centimeters cubed. So that was the other experiment that I did. But yeah, that's that. I don't know, let me know what you guys thought about this video if you want to see more experiments from me in the future. Guided experiments. It's gonna be fun. Okay, thanks for watching, and I will see all y'all in the next one. Stay frosty, folks. Bye.